We are now live
Okay.
in 5 seconds. Yeah,
In 5 seconds. Okay.
we're live now. Good.
Awesome. Great. Thanks, Bhumika, for support. Okay. Welcome, everyone, for lesson 2 of the bootcamp Bringing Machine Learning Models into Production, organized in collaboration with PyLadies Amsterdam and Dexter. Today, we had a lot of things to cover, so we start with a short recap. Then there will be a long hands-on part dedicated for proper deployment setup and how to run batch inference on Azure. And then we finalize with some exercises and home assignments. And I will explain to you what's the difference between them. So without further ado, let's move forward. So recap. As you know, those who are participants of our bootcamp, last session, you were split in teams. So now we have 9 teams led by 9 mentors. How we envision the approach to handle exercises and home assignments. Preferably, start doing it alone, but if you came across some issues or challenges, get to know your team, get to know your mentor. And then, if there is no response or you want to know more or you want to talk to other people, ask these questions in our common Slack channel. And the capstone project that will take approximately 2.5 week time, that's where you're going to work as a team. So I highly encourage you to start to get to know each other, to make sure that when the capstone starts, you're capable of communicating with your team efficiently. So our use case will be provided by Dexter, and it will be about deployment of an energy demand prediction model to solve the problem of PyTel. To make sure that we are capable of doing it, today we're going to focus on an energy demand model deployment. Last time, we briefly got introduced with what MLOps is, and what are the main building blocks of machine learning lifecycle. And we discussed that usually it starts with some business idea, some business problem, and then on only 5% of the cases, it's ended up as a model. And when I'm talking about model, it's not necessarily machine learning model. It could be a simple statistical model as well. And only that when everybody is seeing that there is a need to use this model in one or another way, there is a time to talk about how we can deploy this model. So last week, we explored different types of deployments, and we discussed what's the difference between server-side deployment and client-side deployment in the nutshell. So for us, it's more the question, how powerful could model be and where the model could run, what kind of compute the model can use, and what are the specific latency, throughput, and other requirements. So for the server-side deployments, we decided to focus on a batch workflow, and that's what we're gonna do today. So in our case, we will get data from, in our case, blob storage. Then we'll do some pre-processing with this data. We're gonna run model in parallel manner. We're gonna post-process the outputs. We're gonna store results back to the storage. And then if we want somehow to interact with this model, then we can, for example, from dashboards, make calls to the batch pipeline that will spin up good done processing and spit out the results to the blob storage that is easily pickable by us. And then we take a look as well, if we want to implement machine learning solution, what kind of phases we need to pass through. So in this session of today, we're going to briefly cover phase 1 and phase 2. So phase 1 and phase 2 is all about to make sure that you creating a repeatable, reproducible structure to deploy your model. There is a specific way of deploying it. And then in the phase 3, it's more when your model is already in production, how to monitor it properly. So without further ado, let's start. So I will switching off my camera now and going to this thing. Okay, so it should be big enough right now. And I will explain to you what we're gonna do. So let me open it. My proposal for you is watch alone, and then in your spare time, rewatch it and follow step by step. I will move really, really fast. We don't have a lot of time, but we have tons of materials to share, so stay with me. But also important here to say, although we're gonna cover some specific concepts today, my end goal is to show you the specific tools. In this case, the tools will be in the clouds, but for me, it doesn't matter which cloud it is. The concept work in, let's say, the same way in the different cloud providers. And today you will see how to actually embrace the combination of hybrid approach. So we're gonna do as much as possible on a local compute, so on our local laptops, but making sure that everything we are doing there is traceable, and we somehow do some logging, dataset registration in the cloud. And also what I want to share with you, the code quality is really average there. Why? Because then in the lesson 4, I will show you how to make it better and how to get rid of the glue scenario. That is really, really sad and unacceptable if you want to have models in productions. So let's start. The first thing that we're gonna need, we need to set up some specific things on Azure. There are different ways how you can do it. You can interact with graphical user interface known as Azure Portal. It looks like this. Or you can do things via code or via command line. If you know exactly what kind of resources should be provisioned, you can use specific templates like an ARM templates or the Terraform templates. It's just a combination of resources that should be provisioned with clear description how it should be provisioned. Today, I want to encourage you to do a combination of Azure CLI and the combination of code. And then later we can discuss what is best, what is worst. Frankly speaking, from my own experience, the probability of doing something via graphical user interface is pretty low. It's only if indeed you need to do some specific dashboarding or track some experiments that you want to compare visually, then yes, that's where you're going to use it. In the majority of the cases, you will interact with the cloud or via code or via CLI. Last week, there was a lot of installations that should take place. One of the most, the biggest confusion was created by the request to install Power BI Desktop. So here I want to share with you that Power BI Desktop will be necessary only for the capstone. Power BI Desktop, it's a free of charge version of Power BI, and it doesn't run on any other operational system rather than Windows. So in case that the team has one person with a Windows laptop, it's enough to install it there. In case if there is literally 0 people with Windows laptops, we can see how we can replace it. It's just a tool, and it's a replaceable tool. So that's it. And if you've done all your installations properly, so you should have your CLI installed. So the first step that I'm doing, I'm actually logging in to the Azure CLI. So it's point me to confirm that it's me, that it's logging successfully, and then it's point me to that I'm in. So first that I want to do, I want to create a resource group, and in this resource group, I want to provision Azure Machine Learning. This is the service that we're going to use. So to do this, I'm going to create it from CLI. Of course, you can create from graphical user interface. But one thing that I want to encourage you to do before, I want to encourage you to list all the locations that are there. I know that we have participants from different places of Earth, so to make sure that your Azure subscription has the lowest cost possible, usually the best case is to use the region where you are right now. So just for you, as an example, if you're in India, probably spin up resources in Europe is not the best idea, and vice versa. In my case, I'm located in Amsterdam, the Netherlands, and I know that for me, the region is West Europe. And also, if I want to specify which location I want to pick up for resource provisioning, I need to know exactly the name of my location. So, okay, I know the name. In my case, it's West Europe. And let me just create it. So I'm saying Azure group. Oh, you see, create, and then I define what do I want to create. So the name of my resource group will be MLOps Bootcamp. MLOps Bootcamp. 1 second. MLOps Bootcamp. And then I want to provide location. And my location is West Europe. If I want to double check, I can just scroll here. Of course, I can grab the specific place just to make sure West Europa. Okay. Yes, so it's West Europa. Okay. Right now, what's happened? I just go to resource group provisioned there. So let's check in our portal. So okay. West Europe. Oh, I gave them awesome name. I gave the name MLOps Bootcamp. Great. Okay. Yeah. And now I get my MLOps Bootcamp. So what I want to do right now, I want to make sure that I give the proper name to it. And you see, if you do it from the CLI, it's a little bit error prone, because if you type such a nonsense as I typed in, that's what you can get. Okay. That's why I'm a big fan of using Term templates or Terraform to define what they want to provision and just provision it. And now I think it will be proper one, right? Or it's still MLOps Bootcamp, or I get 2 MLOps Bootcamp. Let me check. Oh, today just my CLI doesn't want to cooperate with me. And you see there is some delay actually. MLOps. Let me do like this. Okay. There is some delay with graphical user interface, by the way. Okay, so we have MLOps, and I want to make sure that we have the proper name for our resource group. So, attempt number, Azure groups create, name, MLOps Bootcamp, MLOps Bootcamp, and then location, West Europe. Yes, it's MLOps Bootcamp. Great. Finally, I managed to do it. As I mentioned before, there is some delay with graphical user interface. Sometimes keep refreshing helping. But let's continue, and then we will go further. So then the next part will be to create a workspace where everything will take place. For creating workspace, the extension for Azure CLIs is required. There are 2 types of Azure ML CLIs right now, the version 1.0 and version 2.0. 2.0 is in preview. That's why I'm using the CLI 1.0. So in the documentation for this lesson, you will find out how to install the extension for this CLI. And in my case, I have it already installed, so I'm just continuing further. So what I'm going to do right now, I'm going to create, I'm using HTML actually to use the extension for my CLI, and I'm going to create workspace, HTML workspace, then create, and then I give the name of the workspace will be MLOps, and the group where I want, resource group where I want to create this resource will be MLOps Bootcamp. So what's happening right now? There will be some of the resources that's going to be provisioned. So it's try to provision Azure Key Vault. We're going to work with it next week. Actually, it's your place to store all your secrets, not personal ones, of course. Then it's provision an Azure storage accounts, and we're going to work with the parts of it, Azure Blob Storage. On top of it, it's provision application insights that will allow you to monitor what's happening with your workspace. And then later, when we're going to work with Docker, it will provision the Azure Container Registry as well. So that's what we happening here. And then the next thing, as soon as it will be done, I'm still waiting to be deployed. And as soon as we'll be ready, then we'll move forward. Awesome. So it says succeed. It means that for now, we have it provisioned. So let's check. This resource group, I will remove it later. So we have our resource group MLOps Bootcamp. And in this resource group, what we have the resources. I probably make it a little bit bigger. We have necessary resources. So we have our MLOps. I will click on it and open it because we will need to see it later in a more closer way. And then there will be other components of it. So we're going to work with the blob storage and the rest of the resources. Everything that I'm doing and provisioning right now is a light version of real life. In a real life, it will be there will be virtual network setup. For example, your blob storage will never be exposed. It will be behind the private endpoint and the rest. For the sake of this bootcamp, we do in the light version to make sure that we incur as less cost as possible while running things on Azure. So we created this. The next step will be to get the configuration for our workspace. We can do it in different way. Again, we're graphical user interface or using different extensions that you installed. I will do a little bit old school way. So what I want to do right now, first, I want to take a look at the list of the workspaces that's currently is available. So it's saying me that I have only one workspace, and it returns me indeed a list, and inside of the list there will be a JSON file. So what I'm going to do right now, I'm going to pick up the query. So I'm going to pick up the first element from this list, and then I'm going to write down this element and the config JSON to my working directory. So what I get right now, I get a configuration from my workspace. The problem, though, with this, that I cannot use it right now directly because the Python class that is corresponding for collaborating with workspace, actually looking for a little bit different keys while parsing. So what we need to do right now, we need to update the keys in this JSON. We can do it in different way. So I will do it in simple and stupid way. I'll just update it here in this file. Usually you can use GQ. GQ is like extension to your, let's put it like CLI. You just install this tool, and with GQ you can work with JSON. You can update anything you want in JSON. But it's not the goal of our bootcamp. The goal of our bootcamp to learn how to deploy machine learning with a batch inference in Azure. So let's stick up to it. So it's a quick hack. Otherwise, we can just download the file from the workspace, or we can use, for example, an extensions to get this file. So let me just double check. So it's resource group, great, subscription ID, and workspace name. Okay, sounds good. So the next step, what is necessary to do before starting working on our notebooks, I'm gonna switch to my lesson 2 folder. So right now I'm the lesson 2 folder, and from this folder I want to create conda environments, which I'm gonna use to train the machine learning model and to do a development of the pipeline as well. So I have a conda installed. I use miniconda. I don't need anaconda. The miniconda is enough from my side. If you have anaconda, it's also okay, just 5 or 10 times bigger than miniconda installation. Anyway, so the question is why I'm working with conda instead of virtual environments, because Azure Machine Learning is orchestrated around the concept of environments, and environment is indeed provisioned with conda. On top of it, conda allows you to immediately spin up completely different environments while making sure that you can use, for example, different versions of Python if you want to play around or do some testing in it. From another side, conda has some disadvantages, and we will see these disadvantages a little bit further in action. So I'm starting with creating conda. I can type. Okay. Okay, conda environment create, conda environment create, and then I point to the file which I'm going to use to create this environment. In my case, it's mlops train YAML file. So in my case, prefix, wait, what I've done, conda env create, or it's again, it's a part of the word. Oh, yeah. Let me briefly check my environments. Okay, clear. Cool. Conda and list. Of course, I already created the environment and forget to remove it, but okay. So then in your case, you will be just create this environment from the file. I already created this environment, and not to spend time on removing it, installing it again. I just start with activating this environment, because that's what we're gonna do here. And the most important part here will be to make sure that while doing it, you are using this specific environment. So where the things where you need to take a look at, first to make sure that it's stated here. Then you need to pick out the proper interpreter. So in this case, I'm just gonna scroll down and find my own. Great, and then we're gonna work with the deployment step, which requires using the notebook. So for this notebook, there should be ipkernel installed. In my case, because I already has an environment, ipkernel is already there, so I can use it. In your case, in the documentation for this lesson, you have a way how to add the ipkernel to your notebook. So that's actually brings us to the following thing. So that's exactly our deployment setup. So what we're going to do today during this deployment setup, so we run through all prerequisites, And then we're gonna pass the data preparations. We're gonna briefly do a really short, quick EDA locally, but making sure that the data sets that we are using, we are registering them on Azure. Then we're gonna continue with model training. We're gonna do it locally as well, but making sure that all experiment tracking while running locally is logged to Azure. And then we will finalize this part with a brief model evaluation and registration of this model. So once again, the model evaluation will take place locally, and experiment tracking registration will take place on Azure. So let me get back here. So we first start with our data preparations. Let me open the notebook. So it will take some time. Okay, here I'm using local server to run Jupyter Notebook. And here I'm making sure that I pick up the right kernel. Okay, so we are set up. What we're gonna do right now, we're gonna work on the energy demand prediction model. And this lesson will be finished with training of linear regression model. And then your home task will be to train and deploy another model. So that's why we'll focus all attention here. The notebook, I will not run all cells immediately because there are some cells that require some sleep in between. So the goal is here to showcase you the power of doing things locally while you can still reuse the resources available on Azure. And I'm a big fan of dataset versioning, because if you know exactly what kind of data you used for, where this data come from, and when you know how the pre-processed data looks like and how your train and test splits look like, trust me, it will save you so much time on debugging things you can even imagine. So let's start with the preparation. So for the preparation, of course, the first step will be importing the necessary libraries. So for this, like just a bunch of, I think, pretty well-known libraries such as Matplotlib, NumPy, Pandas, Skippy, and then as well the Azure ML core to make sure that we can connect to the workspace, our workspace in the cloud, and we can work with datasets. This story is about energy demand model. It used the New York energy demand data. In our capstone, we're going to work with our Dutch town, but to make sure that we know where to start and how to do it, we're going to use this case as an example. So the first step, if I take a look at data sets, we have actually two separate data sets. We can take a quick look on it. So how it looks like, okay, you have timestamp and you have demand. That's what you have. Cool. And then what do we have for weather? You have timestamp, you have precipitation, you have temperature. Okay, so that's what you have. Probably we have a lot of null. I don't know. We will see. So what I'm doing right now, I'm just making sure that I'm setting up the folder, the working directory as the directory where I'm right now in the lesson 2. In the lesson 4, you will see that OS library still has some limitations, but from another side, is much better than hard code absolute path when nobody on another operational system could run it. So just simple procedure, nothing fancy. We're just running and making sure that we read two CSV files while parsing dates, we're merging them on timestamp, and then we casting the demand as a float. And just to see the quick pic of it, how the dataset will looks like, we take a look at it. Okay, so we know there's timestamp, demand, precipitation, and temperature. The next thing what we're going to do, we want to make sure that we have at least some ideas how it looks like. So we're just randomly picking up one specific week from the whole data set and just taking a look, okay, how it looks like. So we'll see, okay, time series, seasonal time series. It's hard to say something about it based on the visualization from 1 week, but at least just to understand what is expected from this type of data. Next thing will be filling gaps in the time series data. So for this, we just want to make sure that we define min and max, the timestamp. So we want to create an index. So right now we create a datetime index for our data frame. We have minimum time, maximum time, and we have our frequency. In our case, the frequency is hours. So we have hourly meetings for the demand and weather. So next thing, of course, to index our data frame to make sure that we want to know how to handle any missing values later. So then we're just checking standard, let's say, standard things, and we insert and we make sure that we have NaN values for all the columns. And then, okay, so nice to say that actually we don't have, so we have some specific, so the data, I should say, the data looks a little bit promising. So there is no huge gaps where literally like have missing days or weeks. So that's why what we can do, we can see how we can start to handling these missing values and to fill them. I'm not saying that it's the best way to do it. There is the best way to fill in, and that's the best strategy. You should be always cautious what you do with the data. For now, we're doing it only for illustration purposes to make sure that at the end we get an artifact that is our model that could be deployed. Then we have continue further. We're filling in the missing timestamp this way, and then we take a look what we can do with other columns, how we can fill exactly this missing values. So we define the strategy how to do it, and then we're going to fill. We fill just demands, but we want to fill the precipitation as well. And then we're just checking what we have now. Okay, so looks much promising. So if you compare it, for example, with, so we have like 2 missing timestamps, 83, 232 values for precipitation, and now it's like almost 0 for precipitation. Looks okay. So overall, greatly reduced, and then probably we can see that if we still have some records with missing values, we can just remove them safely after the moment we create the features. So, and now the favorite part of the majority of the data scientists, data visualization. So just let's visualize to see what kind of intuition is there and what we can expect from this model. So we take a look at the demand distribution. Then let's take a look, for example, the hourly demand, how the hourly demand looks like in 2016. Okay, so we see specific patterns coming up. Okay, let's take a look right at the temperature. So because that's like the 2 major factors, demand and temperature. Okay, and then let's take a look, for example, demand, we see temperature. Okay, so we see that indeed there is some specific correlation, and it's, for example, different for a specific things. So let's continue further. And now we know a little bit more about what's happened with our early demand over a 24 hours period. So with this one, we know, okay, now we can start with computer-specific features for forecasting models. So we're starting with the specific features. So we have a timestamp. From this timestamp, we can extract exactly pretty important features. As we see, it's hourly, monthly, and day of week, because it has influence on our time series. Okay, then the next thing is, where we're working with time series, the hardest part to grasp it that if we get rid of weather, for example, then we have only demand, and demand is our Y, and we don't have X. In our case, to make sure that we can create X, our metrics to use for our standard, for example, sklearn preprocessing library, then we gonna create lagged features. So just generate this lagged features, and we do it for the month and as well for the temperature. Okay, and then let's take a quick look at our data frame, how it looks like right now. So we have our timestamp was indexed by timestamp. we have our demand, precipitation, temperature, then these 3 new features that we added, hour, month, and day of week, and then we have our legged features. So in our case, it's temperature with 6 legs, and then we have demand. Okay, so that's done. Now what we're gonna do, we're gonna do final data cleaning, and then at the end, we're gonna write out training and test data sets, and we're gonna make sure that we register them in the cloud on Azure, so we can version them and can get back to them if we want so. Okay, so again, countermanding and values. Okay, that's what we have right now. Then we can decide how to fill it. Okay, so we have 153 rows. So probably because our whole data set has at least like 45,000 data points, probably we can just safely drop it. But also, I don't recommend to drop in this way, but I want to make sure that you always be cautious of what you're doing. So what we did so far, we started with two CSV files, we merged them, we do some data cleaning, we added some features to it, such as hour, day, week, and we add legged features. So with this data set, we're gonna hold it as an like standard data set, and we're gonna split it in train and test split later. And this data set will be actually saved on the Azure. So here, we right now just writing down to our datasets folder. And I use an OSPath, but in the lesson 4, you will see how we can even make it easier. So we drop this set, and now it comes to the splitting data and training test data set. The biggest mistakes that I see while working with time series, that people just blindly using train test split from sklearn. The problem with this split is that if you're working with time series data, all your data points has a temporal dependency. So actually, something that happens today is dependent on what's happened yesterday. And if you're going to use just simple train test split, while doing it, it shuffles the data. So you are creating a leakage. So while you're going to train your model, you will be leaking the future data points to your model. That's why for this case, there is a specific temporal time split created. But just for the sake, let's say, for simplicity, right now, what we can do, we can just split our data sets that we managed to achieve based on some specific data. And we have data from 2012, or yeah, 2012, sorry, 2012 up to 2017. So what we're going to do, we decide that we want to keep 1 year as a sort of like validation year, and it's going to be our test split, and then use our train split to the training and validation. And we making the split in this way. And while making the split, we just drop in the files to our local folder. While we're doing this, you will see in a bit. So, okay, we did this. Nice. So before starting doing any modeling, what I want to do, I want to make sure that we are capable of register our data sets to our workspace in the cloud. To start with this, I'm just getting connected with the workspace, and it's happened while reading information from the config.json file. And then I'm just getting a pointer to the data store where I want to upload data. So the next step will be to upload the whole folder datasets to the cloud. So you see it says upload estimated 5 files. So it's uploading files. Let's wait. Files uploaded. Awesome. So what's happened now? Let's take visually. So we are here. I'm going to my blob storage, going to the blob service. And remember, we created the folder data. Here you are. This is your folder. And in this folder, you see all your CSV files. Of course, it's pick up as well raw data, but it's nice to have it here as well, so you know at least where you start. But How it helps with data versioning. It gets just in blob storage, and it's not connected at that moment to the workspace. And if we're going to train the model, how to say that I was using this specific data set for training of this model. So what we're going to do further, we need to create the so-called data set. The workspace is working with two types of sets, or it's a data set tabular, or it is a data set from file. So in our case, because we're working with CSV files, we're using tabular. So what's happening right now? Right now, I'm picking up the CSV file that is stored on the Azure blob. It can take some time, so let's wait. So right now, I'm working not with these files. I'm working already with the file on the blob storage, just to make sure that it's our set, that I'm not cheating. Let's take a look briefly what it is. Okay, it looks like our files start from the 1st of January 2012. Okay, so it looks like this and what we created. Okay, great. And the next what I'm going to do, I'm going to register this data set at the workspace. So while I register this data set at the workspace, of course, you can call it, give it the proper name, you can give it a proper description to it. While it's there, it's get versioned. So before showing you, let me continue with the same story for our train and test data sets. Again, right now, I'm going to the pointer that's showing the path to the blob. Then I want to make sure that this is the train data set. And it should look like our process, but it's shorter because it has 1 year cutoff at the end. Okay, cool. And then I want to make sure the same with test data set, just for the sanity check. And I see here indeed, look, the test data set starts from the 1st of July 2016, as we told about it. Great. So then we are going to the register these two data sets as well. Awesome, great. And now that concludes at least this part. So now let's take a look what's happened here. So here, nothing changed. It looks like, okay, the same data, but what if we take a look at our machine learning part? Here you have a data sets. And if I go to data sets, I'm seeing the 3 registered data sets. Why I'm doing this? Because while training models, I'm going to point to this data set, and I'm going to use this data set and not the local one. The same story for the model evaluation while testing. And if something goes wrong during the pre-processing, you can always get back and explore this data sets. So if you want to take a look what it is, so you see, okay, there we have some more information. You can even explore it. So a lot of things here waiting for you. So just need some time. Okay, yes, indeed, this looks like our data set. Great. So we have data set registers. What's the next step then? Up. And then great. So the next step will be to train the linear regression model on our train data set. So let me just close this part and open the training of linear regression model. So once again, I'm checking information here, and I'm checking the kernel. Kernel is here, so we can start. What we're going to do right now, we're going to really quickly train a linear regression with recursive feature elimination. We're going to package it in the sklearn pipeline, and that's what will be the thing that we're going to deploy, because we're not going to just deploy a model standalone. We're going to deploy the pipeline that expected data with a specific format, do some specific processing with data, and then run predict. So standard import models as well. Okay, here you see more because we need to export a lot of things from sklearn, some things from Azure ML, workspace dataset and experiments, and of course our favorite pandas, NumPy, and Matplotlib. Okay, great. So I'm going here as well. First thing, I need to pick up the workspace. So make sure to that I connected to this. And then that's where the nice parts come in. So what I'm doing right now, I'm running this. And what's happening, I'm going to pick up the data sets that are right now located in the cloud. And on top of it, this data set is versioned. So while going to train my model, I know exactly what kind of data were passed into my model. And next step, to make sure that we're capable of working with it, we need to convert it to the pandas data frame. Okay, so that's our train test. We saw it before. Let's move further. First of all, we need to drop 2 columns. We need to drop the column timestamp because we already has our month and day of week feature. And another thing that we want to drop off is our target column demand. So let's drop it. And remember, I mentioned to you that we're going to train model locally, that we want to log all experiments while training things locally. Why? To make our life more easier and to make our actions reproducible. So what's happened here, I'm creating an experiment. I pass the name workspace and the name to this experiment. I decided to call it linear regression. Naming convention is also a really good thing. So as soon as I started this cell, the login started on Azure. And the first thing that I logged there, it's my dataset name and dataset version, because I want to make sure that I can get back and trace the datasets that were my model were trained on. If you want to see how it looks like, let me go here. You see, I got the first runs, and it says running. It says was submitted by B. That's the name of experiment that I gave. For those who are familiar with MLflow, this is almost the same concept, and it's actually, I should say, probably built on top of MLflow. So let me get back here. So right now, everything we do will be logged if we pass the run.log element in it. So we're starting with predictive model pipeline. To make the long story short, what I'm going to do, I'm going to build a pipeline that first will apply one hot encoder on a categorical columns. And to do it, first, I need to define actually the number, the position of these columns. So I'm just looking where these categorical columns are in my pandas data frame. And then I'm using the column transformer because some of the features of one hot encoder were deprecated in the latest version of scikit-learn library. So in this case, I'm just I'm creating a column transformer. And what I'm saying to it, I'm saying that pick up these 3 columns in my case and use one hot encoder in it, and while keeping sparse false. And then I pass an important element remainder, because if you pass remainder, it says to you a remainder path through, it says to you do nothing with the rest of the columns, because we had a lot of columns, remember, and we don't want to drop these columns. We just want that these columns left untouched. So next one, just simple linear regression with fit intercept true. Great. So to do some hyperparameter tuning feature selection, we're going to do the cross-validation, the training set. And as I mentioned before, we should be really cautious while working with time series. That's why we are using the specific class that was created by sklearn specifically for time series. I'm going to run a time series split. So how it works, let me visualize it for you. So to run cross-validation, I'm going to actually pick up my training sets and split it up in this way. So I will have actually 3 splits, and you see visually how the splits taken place. Remember, it's time series. We need to make sure that we are splitting data in the logical order. We are not shuffling them, and we're not picking up some random points from the future. It's really, really important. So yeah. And then what we're going to do, we're going to create another part of our pipeline will be RFSEV object. And for this one, we're going to pick up our linear regression as an estimator. Then for cross-validation, we're using exactly this split that I just showed you before. For scoring, we're going to take a look at mean squared error. And then we just pass it to the pipeline. Great, so that's our pipeline, what to expect, how it works. First, we start with a preprocessor, we pass in the data in, and we transform in this data with categorical columns with one hot encoder. And after that, we apply RFSTV with our linear regression in it. So next step that's gonna happen, I'm gonna train the model. So fitting the whole pipeline. And in this case, we picking up our X and we getting back to our trade data sets and we picking a target value from it. Okay, great. So we get what we need. And for this sake, we want to log these pipeline steps just to make sure we remember what it was, what exactly steps were done there. And the last thing that we want to do here, we want to save this trained model in the pipeline object. So now we just get our linear regression pickle. Great, we did it. And while doing that, we do some logging still. And then let's take a look at our cross-validation results. And I want to log all necessary information. So I'm starting with logging exactly the best cross-validation negative mean squared error. Then I do some plotting, and in this case, I want to plot the cross-validation errors with each subset of features. So then I know, let's say, which features are most useful to my model. So I'm doing this, and while doing this, what I do as well, I'm logging an image. And you can say, why do you need to log a plot? Why it's so important? Because trust me, when some time passes, you will be really looking for what can I do to make sure that I get the results I want and how I get to these results and why this model was validated in this way. So I'm logging these plots in the run. Then I want to understand which features were selected. And then I want to identify supported features of the selection process. So I do just this. So that's we see which features are supported and which are not. And then I want to make a plot for model coefficients for each included feature. So then we'll see what exactly, what are the effects of each coefficient on our model. And I'm logging this at the plot as well. And the last thing that's left is to set there are run complete. Okay, so if I run complete, what we have right now, you say it says run complete. So we have everything that we done locally, we have right now here. The beauty of it, because we know where it's located, what's the commits associated to it, how long take. We pick up some specific metrics, so you can take a look at it. We pick up some specific plots, and everything is there. One disadvantage, I'm using this dark shadow mode. So if you want to make sure that you see the whole plot clear, then you need to not to use the dark mode of it, or to rearrange your plots to make sure that your plots are visible in the dark mode as well. So the thing is that we've done this part, and we are moving for the next and the most interesting is model evaluation registration. So to evaluate our model, I have a short evaluation script. What this script is doing in a nutshell, let me start to run it, and then I walk you through for the sake of time. So just let me call this, and again, missing letters, Python, then I have evaluate model, and I pass in the name for the model, and the name of my model is linear regression. Now, of course, I said put on. That's nice. So what's happening right now? There is specific horizon forecast that is set up, and the model that we're using is a one-step forecast model. So actually with this model, we can predict one data point for 1 hour. What we want to do, we want to see if we want to predict for more for a specific horizon, then there are specific actions that we can do. So we set up the specific functions like generate forecast, and what's happening there. So we use our trained model recursively. And what we're going to do, we want to predict multiple feature timestamps. So in this case, each iteration from our time t plus 1 to the forecast horizon h that we define here. So the predictions from the previous steps will be the lagged demand input feature for subsequent predictions. So a lot of things indeed. So we're doing some shift. We define functions, and then we want to evaluate forecast. For this evaluation, we define specific metrics that we want to see, and that we want to produce some plots for these metrics as well. And while doing this, we again make a connection to the workspace. We are calling the dataset from the cloud, our version dataset. And in this case, we are calling our test dataset because we want to make sure that our model performs as well as it was performed before. And we are doing this evaluation. At the same moment, we drop in files with predictions here because we want to explore these files later. And we as well drop in the things to the folder to make sure that we can do some plots. And these plots are as well logged to the cloud. So the script is running still, as almost done, because it's producing plots and it's logging everything. So we can just take a look here. And if we go to the cloud, it's finalize. Okay, you see, it's what we've done here. We created the new experiment, the evaluation of the model. And in this experiment, we can investigate more. We logged in specific metrics that can help us to decide which model is good, which model is bad, which model to pick up. On top of it, we have more metrics here. You can just pick up whatever you want to see. And we as well generate some outputs, in this case, images that we can view here. So we actually plotted map MDRA and MP here. So, and all of this information and stays with us as long as you using this. So usually, what are you going to do after the steps? There is some specific decision that should be taken to make sure that as soon as you're done, to make sure that you are capable of evaluating the model. And sometimes you can have different parameters that you tuned, and then you want to see what's happened. Sometimes you want to compare it with different models. There are different versions that can be that you want to achieve here. So for us, before just blindly register model, what do we want to do? We want to take a look at what we predicted and take a look how our model performed overall before deploying this model. So right now, let me check. There is one thing that is still running. I'm really curious what, because the run is already completed, right? Yes, the run is already completed. Great. Okay, so let me check what is still there. Okay, great. So we are done here. And the last piece before deploying it, we want to take a look at the results. So remember, we were doing this forecast with horizon of 6. It was for 6 upcoming data points. So let's take a look on what we have, right? Okay. So we have explore predictions for you. So you can play around with it and you see what's there. Everything is here, so just let me start it briefly. Yeah, here I'm just having linear regression. You can work with another one. So I'm just here picking up our model. And then what I'm going to do, I'm going to inspect this forecast. To inspect it, I want just to pick up specific time range. Let's pick up 1 week in July 2016. Okay, so what we're going to do, we want to show actual demand and forecast over this period. And then we're going to take a look at the multiple forecast. So let's take a look at it. And then go further. Okay. So what do we see? Strange things happen. So if we take a look at actual demand, and if we're looking for our forecast for T+1, we see that the farther we go, the more errors we get if you want to compare, for example, T+5 with T+1. So then we go to take a look at absolute percentage error. So, okay, what's happening here? Again, the far we go in the horizon, the more errors we get. But what's important here to say, our forecast error will be progressively worse because actually we accumulate all the errors because we're using recursion. So what we want to do, we want to understand whether our, let's say, forecast error will going to increase as time is going on or not. And we want to indicate, it helps us actually to indicate how often the model should be retrained. It's really important because it plays a huge role, especially for performance of the model, the compute resources. So, okay, let's take a look at it. This is our forecast errors of entire data sets. And then we want to check, so are there any specific time periods when the model performs poorly? So let's group and produce 3 plots, average errors by hour. So we'll see we have some downsides. Then we have average errors by day of week. And then we do average errors by month. Okay, so this gives us a little bit more insights on what to expect from performance of our model, what kind of errors our model picking up, and also confirms that actually our model has like highly visual seasonality, and its seasonality regarding the days of the week, its seasonality regarding the hours, and its seasonality regarding the month. So the year seasonality will be picked up as well. And the last part will be actually to register our model to the model data registry to make sure that we can actually deploy it later. And we are deploying this exactly model that we want to do it. So we can do it in different ways. The simple way to do it and the fastest way to do it via the command line. So let me make sure that the command line acting as expected. Okay, sometimes it gives some bugs. So I'm doing Azure ML model register. Then I give the name for my model. It's linear lowercase regression. And then also you can add the framework to make sure that you know exactly which framework you're using. And you can provide a path where your model is situated. So I want to add here the model framework. And then go, it's scikit-learn. And then go to the path where my model is. And in this case, it's my linear regression recall. Okay. While doing it, I get file names are required and what's missing. I'm missing and let me add the n before linear regression. And just run it. So this will conclude our deployment setup. And then we move, if the registration is successfully, we move to the deployment part. Okay, great. What we see right now, if we move back to our Azure Machine Learning, we see that we have a model right now, and this is our registered model, linear regression. Why it's important to register and version your model? Because in the future, if you need to update or replace your model, there are different options how to do it. And here you want to make sure that you always know with which model you worked with and on which data sets this model was trained as well. So that's exactly leads us to the next part. And one thing that I want to share with you, although we didn't touch it directly today, but never hard code secrets in your code. I mentioned that the code will be refactored in lesson 4, but I want to make sure that you know that if you hardcode something, like something very specific, secrets, especially when we're gonna work with password for ASP&, next lessons, everything that you hardcode and push to Git will be immediately picked up by bots in the internet. And somebody will just use your Azure account to run their own compute until you notice it. So please don't do this. So for local development, we're going to use .env files and make sure that it's added to .gitignore. And for cloud developments, we're going to use Azure Key Vault. So that's what we've done so far. We're making sure that we get some data, some model, and everything is versioned. Although we were using our own compute from our local laptop, we make sure that we get everything logged in nicely and neatly in the cloud. And it will help us to actually prepare our batch inference. So one short hack that we're going to do right now, I'm going to run a notebook to prepare files for batch inference, and then we go hands-on with setup and scheduling of Azure machine learning pipeline that's going to produce this batch inference for us. Okay, so let's get further. We move to the points that we have our pipeline. If we want to make batch predictions, we need to have batch data. So to simulate this data, we're going to pick up 1 week from our test set, and because our model was not seen yet before, and we're going to generate a batch of files to make sure that we're going to use these files. And we're also going to register these files to the cloud. So we're starting with just simple import as again, nothing here, work here. We create a batch folder that we're going to use for it. We connect to our workspace. And what we're going to do, we're retrieving our test data set from the cloud. Okay, so that's our data set. We saw it before. And then we pick up one specific week. We drop target timestamp, and we convert it to the NumPy arrow. And that's what we're going to do. We're going to iterate via this NumPy arrow. We're going to pick up actually the files from it, and we're going to save the files into the folder. So that's going to be the batch file. You see, it just generated how much? 160, 168, 169. Okay, so let's go further. So we had our batch data. But before starting working with them, I want to upload it. Last time, we used data store upload to upload CSV files as a tabular data. For now, we're going to upload a bunch of files. So let me upload. It says estimated 168 files. Okay, it's in the process of uploading. While we're doing all of this, to make sure that we have data to perform our batch inference. And the last piece is to register it. And that's where we're going to use, for registration, we're going to use dataset file. So remember, with plain CSV files, we were using dataset tabular from delimited. And here we're using dataset file. So done, it says it's registered. Great. And let's take a look at it in the clouds, what we have here. I really love this idea. Let's take a look at the cloud. Cool. Okay, so let's go to our data sets. You see what we get here? We get file. So if we get there in the batch data, it says, okay, what it is. If we can explore it, it says that I'm going to pick up randomly some of the files and just return you back what you see there. So actually, it's point us to the files, when it was modified, what's in there, and give you the brief preview what's there. Remember, we just pick up our test data, we make sure that we drop the target, we pick up only 1 week, starting sharp from Monday and finalize it on Sunday, and we want to see what we can get out from it. Okay, cool. So we registered our data, and the last piece that we have for today is our batch pipeline. So you see, just for this pipeline, how much work should be done before to make sure that for this pipeline you have all inputs that you need. So usually when you're working with batch pipeline, we are working with a scoring script. It should be a score.py, something like this, and we're going to generate this file in a minute. And the whole point of the script is to do two things. First part, it's initialization. This is called when the pipeline is initialized, and that's where the model load from the model registry will take place. And the second part will be run mini batch, where we can define what kind of things we want to do, how we're going to want to generate predictions from each batch of data and getting back our results. So we will create the script actually in the next step. And the next step is already here. So let's dig it down to the last part. And by the way, when the cluster will be provisioning, we'll have some time. I will let you know when. So just in case, if there will be some questions, something, probably there will be time to answer them. Whew, the last part, the greatest and the biggest batch pipeline. Of course, we start with connecting to the workspace. And another thing, to run a pipeline, we need to define a specific compute that we're going to use for on Azure Machine Learning. For all these things that we've done before, we were using our local compute, but for now, because we expect that this pipeline will take place in the cloud, we already upload data there, we want to make sure that it has a virtual machine attached to it to run it. So what's happening right now, I'm set up the cluster. It's one of the, it's hard-coded here for now. It's a small compute instance. If you want to know more about different types of compute instances, where to use which are general purpose, which are memory optimized, which are EO optimized, then you can get back to the resources that we are sharing with you. It will be in the lesson 2 theory, so you can read about it. And what's happening right now, let's take a quick look. It says creating. What is necessary to know about it as well? So what we're doing, we attaching a compute cluster to our Azure Machine Learning workspace. And we are attaching in this in the way that we say stay idle, don't require any charges, and wait until we call you to do something. So in this case, we're saying that we're going to provision this cluster with 0 nodes, with minimum 0 nodes. So by default, it will be 0. And maximum, we say I allow only 2 nodes to be processing. So while the processing started, you see it says compute, provision in progress. Magic, right? We're just doing some comments and it gets anything that we want. So if we got to compute clusters, it says succeed. So what's happened here? This instance was provisioned for us. Let's take a look what it is. So it's our compute. It has 2 cores and 7 GB RAM. So it's and 14 GB disk. So it's pretty small, but for our purposes, it's enough. It's Linux machine and it has CPU. It's not GPU. We don't need this beast here. And it says idle. So it means that right now it doesn't running. It just waiting patiently until we're gonna use it for our batch pipeline. Okay, so to create, I want to make some folders and to make sure that I drop everything in these folders. But before just creating the score.py, I want to make sure that the model that I registered, that's indeed the model that I need, and that I want to get this model and to check whether this model returns prediction is capable of returning predictions on the batch of files instead of one. So let me run this one. Okay, I got exception. Let's check what's here. Okay, modeling, ratio not founded. Okay, let's check what we've done. And if I add a workspace, let me do it differently. Let me do it like this. First, I want to make sure that I can get models because we already registered a model, and I just want to print model list. So what I'm doing right now, I'm just retrieving the list of the models that are registered at the model list that are registered in our workspace. Okay, so it says we have this, and the name of the model is linear regression. Great. So it sees this model, and that's our resource group, MLOps. Yeah, though, just to make sure that's right. Bootcamp, great. So just right now, try me to get it. Yeah, it's linear regression. Because sometimes if you do a misspelling, last time I get linear regression instead of linear regression. Okay, let's check. Okay, so it says current working directory, the regression could be fine. It's okay. We're gonna make it, right? Let's double check. It's live demo. That's always what you get during the live demo. So the model name linear regression, it's correct. Just to make sure that's registered to the proper workspace. Yes, it's registered to the proper workspace. Okay, great. So the model is here. The name of the model is here as well. Let me just point to the specific workspace. I'm not sure that it's picking up it properly. So let's run it. Oh, it looks like now let's find it. Okay, let's run it again and print it. Yes, now let's find our model. Okay, so we get our model. Let's unload our model. Okay, yes, indeed, that's what we done. Remember, it was linear regression. It was the whole pipeline. We have this one hot encoding steps. Then we have an estimator. So what I want to do right now, I have this mini batch files locally. So I have this batch data, remember the CSV files, and I just want to create the list of the elements to make sure that my model will be capable of iterating through this list and making predictions. Because before deploying anything to the cloud, I want to make sure that it works at least locally. Okay, great. So that just created pointers, a list of pointers to the location of my CSV files. And here I introduce the function to run minibatch. What's happening here, I'm saying, go to this list of the files, these physical files, and from read each files as a NumPy array from text, and do model prediction on it, and return results of the prediction in this specific format. So let me make sure this function is running, and let's try to see how it works. Okay, it looks like it's works. So what's happening right now? Our model that we just unpickle is capable of actually reading a CSV file and getting a prediction back to it. Great, sounds nice. We are ready to deploy. Oh, now you see, oh, it looks like really interesting. Okay, so the first thing that what we're going to do, we need to create this score.py script. So in this case, we're just dropping it to our folder. For Windows user has created this. I mentioned that there are different ways how to do it. We explore it later, but for now, we're using this. So what's happened, I just created the score.py file. Let's take a look at it. No, it's in batch data, sorry, batch pipeline. Cool. Score.py, what we have here the following. First step, we initialize the model. We keep it as a global variable because we want to reuse our model after initialization of the pipeline for all the runs. What's nice, the pipeline initializes once, so you don't need to reload model again and again and again. And the run mini batch will run every time when pipeline is called. So that's the same things that we've done before. We just drop it in a Python file that's going to be sent to the cloud to run our prediction there. Cool. So this is done. What we need as well, we need an environment, and it will be a content environment that's going to run it. But for the content environment, we don't need to use everything that we were using here. If you want to compare it with, let me first drop it to this place. Great. So what's here, if you take a look at this environment, okay, you see that it requires less libraries. Of course, prediction requires less libraries than we need. We don't need the whole bunch that we're using here. And it's usually a good practice to split environments for inference and environments for training, because training requires a lot of visualization, a lot of specific specific tools for cross-validation, hyperparameter tuning that's completely unnecessary for the inference. So tip, make sure that you have always separation between your inference environments to make predictions and between your home environments, train environments. And another thing that I want to point out here with the condas, there are some libraries that you could install via conda channel. So you use conda install and it picks it from default channel. There are some libraries that you can install from conda force channel, but unfortunately there are some libraries that can't be installed only via pip. What's important to say here that the best practice to work with conda, first install as much as possible with conda, and only at the end install things via pip. So only for the libraries that couldn't be installed via conda. In this way, you will prevent a lot of issues. Another thing about library pinning, we'll cover it up later. So let's get back to our batch. So what we need to define a context where our score.py file will be running in the cloud. So what we're saying here that if we want to pick up our score.py file, we want to make sure that this score.py file will gonna package in the Docker CPU, simple Docker containers run on CPU. Remember, our virtual machine has only CPU, no GPU ever. And then to run this, we need to use our conda environment that we just created for inference. So while separated this, now this is the cherry on top of our presentation today, and that's exactly the creation of the pipeline. What I love by working with a pipeline, that you can define what do you want to do in which steps, in which capacity. So here, what we are doing, we define a so-called parallel run step. And what it allows you to do, it allows you to process files in parallel. So if in our case, we have pretty small data set, it's 168 files. Imagine that every week we get this data to make our predictions. So it's like the worth of data for 1 week with a 1 hour interval. But what if we need to predict energy demand with a quarter interval, for example? It means that 168 files immediately goes to the from 1 hour to 50, like to 4 times more. Or what if we need to predict energy demand for not for one place, but for all places in the Netherlands? So that's where the amount of data that should be processed just raise exponentially. So what's happening here? We picking up a pointer where our data are. Remember our batch data folder in the cloud. Then we picking up where we want to store our output. And then we define in code the configuration. So we say, go to the experiment folder, pick up the score.py file, pick up 5 files and process them. We give some threshold. So we say if the amount of errors will be like this, stop the processing. We don't want to use compute if there are some errors popping up. And then we define environments, our inference cluster that we provisioned, and node count. And then what's happened next, we define parallel step name. My preferences usually will be working with datetime in the part of the name, because it allows you to understand at which time the prediction was produced. And if your prediction will be picked up, for example, by another team, they're at least aware of when this prediction was generated. So it's a nice thing to take in mind. And then we define the parallel run step. So we say that the parallel run step, it will start with this specific name, and it will be done on our batch data, and it will send the data to our output dir folder. So let me run this part. That's where we define the steps of the pipeline. It reminds a little bit, okay, that's a really nasty error, and that's what we're gonna discuss in lesson 4. Although the specific library is installed, it says that it's not yet installed. So it's really, really interesting, but we'll handle it later. It's nothing crucial for now. For inference is not needed, but it's important to have. Okay, so just let me rerun this step to make sure that we get it right. Okay, so our steps define. So, and the final piece is putting the steps into pipeline. and run the pipeline. And that can take a lot of time. So while it will be running, I will cover briefly small things that you can do with pipeline. Let me start it first, because it will take approximately 10 minutes to do, and I see that we're almost running out of time. So probably I would love to show you the results. So what's happening right now? So right now, first of all, we created an experiment. Experiments, we get the name New York Energy Demand Batch, and we say that we want to submit this pipeline there and run it here. So what's happening, in a nutshell, there is a Docker container that should be, we have a virtual machine provision for us to run our pipeline. Right now, a score.py file with environment is packaged into the container. From the container, this container will be deployed. You see it says not started running, it just starting. So if you want to see how it looks like, if we go in here, so for pipelines, you see it says running. Then for experiments, we got this New York Energy Demand Batch experiments. It has a lot of things in it. It had child runs as well. You see it's not started yet, so our compute is starting to woke up from it's time to work for a compute cluster. So if we take a look at our compute cluster, we see that, okay, it's still have 0 nodes. So as soon as everything will be prepared for running the pipeline will call the cluster to make sure that the cluster will be expanding and provisioning 2 nodes for us to do our processing. It can take approximately 10 minutes or more. And after that, as soon as the cluster is spun up, the whole process of prediction takes a pair of seconds, literally. Probably you can say, oh, then why we need to do this if we know that the completion is only 2 seconds? That's the possibility to use it if you know that you need to process a lot of data. So in this case, it worth waiting for it and then using it. So otherwise, there is another option. You can always keep your, for example, compute instance and pay for it to make sure that it's all ready in a seconds to process your data. So while you see that the preparations running here, lots of things going on, there is a Docker container pulling on. So in case if you not manage to finish it, what will be the next step? It will be to take a look at the predictions that our batch pipeline delivered. It will be exploration of the predictions in the cloud, and then it will be publishing the pipeline and usage of its REST interface. And that's the beauty of the pipeline. Because it has REST interface, you can call it from applications. So imagine that our dashboards can call our pipeline on a specific schedule to get data to populate the dashboards. That's the beauty of automation in action. So that's what we're going to do. And the last part will be, if it's done, is we can even schedule pipeline to work it. So while it's running, let's take a look at the home tasks and okay, so it's running, it's in process. Great, it's installing things. Okay, it's rooting now. Root conda package doesn't exist. Interesting, we'll see. So the installations are happening there. If we go to experiments, let's check the child runs. You see it says preparing, and we have, here we go, here we have compute target. So that's where the compute target is wake up and says, okay, there is something coming for me to do. I'm here to support you. And if we go back here, that's what's happening right now. So we want to pick the data and want to prepare the data. So let's take a quick look at what is waiting for you. So that's what we covered so far. We prepare some files, and then we provision compute, create score.py, inference conda, created the pipeline, and we waiting for it to be published. And then another thing will be schedule pipeline. So what do you have as a home task? So you have, this time you have exercises and home assignment. So what's the difference? Usually you can take it, you can find it there. What's the difference between exercises and home assignment? Exercises is just about working with simple tools. And what you're gonna do eventually, you're gonna For the exercises, let me open it briefly. Tasks. Okay, and show it like this. So task will be to register machine learning models. So to register via CLI, via Python script with different Python methods. Then another exercise will be to attach and remove inference cluster, to play around with it, attach, remove, and then there will be the exercises to the scheduling of the pipeline. So schedule pipeline for this period, schedule pipeline for this period, deactivate the pipeline, and also explore what kind of other possible steps you can have in your pipeline. Right now we have compute, we set up compute, we call in this compute. As soon as the calculations are done, compute is returned back to the idle, but probably we can have a pipeline as a hint that actually can process, make sure that the compute instance will be killed after the processing as well. So there are a lot of things to actually go through, and the home assignment will be to go through the Reach Model Training Notebook. So you have already the part covered with dataset registrations. Then you can pick up the Reach Model Training Notebook, train Reach Model Training Notebook on the data registered in the cloud, and then evaluate this model while making sure that you're using runs and running all experiments that you have, and then to go to create your own first batch inference pipeline. And for now, we have pipeline that's running in Python, but we can do much more. We can attach, for example, a cluster that is capable of running Spark on it. And with Spark, we can create forecasts for a lot of cities at the same time to predict demand. Or we can even probably create an energy demand forecast for the whole world. You never know what's expected for you. But let me take a quick look what's happening here. Okay, it says fail. It's really interesting. So what's nice, at least we get the error, our first error. Awesome. So let's check the logs. Why it's failed. Okay, for the run 2. Okay. Not found. So it looks like there is some disconnection right now with the Docker images that you can pick up from Azure. So there is some internal things happening, and it actually is not capable of retrieving a Docker image, unfortunately. So yeah, but you see what's nice? It's failed and it stopped the compute. So it means that it's failed, but your compute is not running. I wish I could show you how we can query the results, but if you will just go and follow this, follow the tasks, follow this notebooks step by step, you will be capable of training and register, evaluating, and creating pipeline for linear regression, and then to do the same for the rich regression. So I think for now, I can actually reschedule pipeline to make sure that I can get it again, because I want to make sure that it's done. It's so sad that image is not available. But anyway, sometimes it happens. So you see there are a lot of dependencies in it. But I think that's it for now. So what we have so far, let's take a quick look. We did a lot of things today. So we start with a short recap. Then we take a look how to set up a deployment part. And then we moved to the usage of tools available in the cloud for you to make sure that everything that you do could be logged and could be traceable. And what's nice here as well, for those who are really concerned about the cost of running it, if you want to see how much it costs to run all of it in the cloud, I will show you. You will be really surprised to see the whole price. Sorry, I forgot to switch to English. It's the interface. It's another interface and then another language. But if I open the resource group and I take a look at the costs, so I was running this, the pipelines today at least 6 times to make sure that everything is working. And for this 6 times runs and for doing a lot of things. I paid €1. Woohoo! So I think that's conclude my session for now. You know where to go. You know what to do. There's a lot of materials to go through. And next week, we're going to cover serverless deployments. And after that, in lesson 4, we're going to cover the best practices and how to avoid situations when people actually confused and don't know what to do with the model. And we will show the importance of logging, importance of monitoring, and error handling as well. Okay. Thank you so much for being with us. Bhumika, are there any questions? Because I see that we are already away from the time.
No, we do not have any questions in the chat. So
Probably today was a lot of things.
yes.
But just people know how the life of machine learning engineers looks like. Okay, great. Thank you. Thank you much for your time. And I think Bhumika, it concludes our session. So please stop the streaming.
Okay. See you. Have a good evening and thank you for watching. Okay, the stream is concluded.